everyone, I'm just getting ready to record our video from our first lesson in Chapter 1. I'm almost ready. There we go. Chapter 1, Sequences and Series. We're taking a look at Section 1 from Chapter 1 on the arithmetic sequence in this particular lesson. What the plan is to help you derive the formula for an arithmetic sequence and then work with it to solve various styles of problems. Vocabulary that I would like you to be watching out for: sequence, arithmetic sequence, general term, common difference, or constant. So please record those and make sure that as you listen to this video that you take note of these words when they come up. These are words that we need to be able to be comfortable with in our conversation with one another. So first of all, just asking you, what is a sequence? When we talk about a sequence mathematically, what are we talking about? Well, some of you would say it's a pattern of numbers, it's a line of numbers that have some kind of mathematical connection, and all of those would be correct. The literal definition of a sequence is that it's an ordered list of objects that follow a pattern. Notice it says objects, not just numbers. Although a lot of what we do in mathematics involves numbers, it can also be a pattern. Like the following. If I gave you the following pattern and asked you to decide if this is the first term, and this is the second term, the third term, and the fourth term, what would the fifth term look like? So pause the video and try and think about that yourself. If you were to look at it, this one is a pattern of blocks of 3. And then you take that 3 and add another 3. And you take the 3, and add another 3. So now we have, for the third term, it's 3 groups of 3s. For the fourth term, it's 4 groups of 3s. So for the fifth term, it's 5 groups of 3s for 15 blocks. This next one, I find the pattern a little bit easier to see if I go from the right to the left. So let me talk about that. You can see how you've got this pattern of 2 blocks on the end of everything. And then this other sort of rectangular shape, let's take a look at what it is. This one is 4 by something twice as big, 8. This one is 3 by something twice as big, 6. This is 2 by something twice as big, which is 4. And this is 1 by something that is twice as big, 2. So, okay, you can see it's 1 by 2, 2 by 4, 3 by 6, 4 by 8. So that would assume that this next one will be 5 times 10, and it'll have a little 2 left over. 5 times 10 and a 2 left over is 52 stars. Okay, what about the following numbers? Pause the video for a moment and look at these numbers and ask yourself, do they have anything in common? Well, when you look at them, you think, well, okay, this one's getting larger, this one's getting smaller. So that's different. But if I look at it, this one's always has a number 5 in between. I'm adding 5, 4 plus 5, 9 plus 5, 14 plus 5. So it makes it constantly adding something. This one, I'm going down, so I am constantly subtracting something, negative 8 here, negative 8 there, and so on down the line. So what could be a formula? So before I actually taught you the arithmetic sequence formula, I got you to try to find this formula. So do pause the video and try it yourself. One thing you'll find when you're finding the formulas just in the blind like this is that it's kind of confusing. You kind of feel like, I don't even know where to start. Some people are good at it, some people aren't. It's a very sort of nebulous process. So let's see if we can take some of the mystery out of it. So first of all, in an arithmetic sequence, or a sequence of numbers is said to be arithmetic when the difference between the terms is constant. So there's always the same number being added or the same number being subtracted. You can also call this constant a common difference. So let's see if we can come up with a formula for the arithmetic sequence. And we're going to use the same sequence of numbers that we had from earlier example. So let's take a look at the first one now. Looking at this one, it's 4, 9, 14, and 19. So let's say we wrote it like this. The first term is 4. The second term is the same 4 plus a 5 one time. The third term is the same as a 4 plus 5 times 2. The fourth term is 4 plus 5 3 times. These give me my numbers. The numbers of my sequence are very, very simple. 9, 14, 19. So here is my general formula. Let me make sure I've answered the question. What is the formula for these guys? So here it is. You're always for the nth term of any arithmetic sequence. You start with the first term plus n minus 1 times the constant. And notice the constant in this guy was 5, but this is 1 less than 2. This is 1 less than 3, and so on. So the beauty of it is this. Once you've identified that a sequence is arithmetic, you can use the following formula, that the nth term is equal to the first term plus n minus 1 times the constant. This, by the way, this d is considered the constant. So if we were to try that and go ahead with this one, now I think I wrote it down. Yes, what you would have is the first term is 60, that d is negative 8, and when you put that 60 plus n minus 1 times negative 8, if you multiply everything out and clean it up a little bit, you should get negative 8n plus 68. Okay, so let's use this newfound formula that we have to answer the following questions. If you were given the following arithmetic sequence, 10, 15, 20, and 25, what is the value of the first term? That one's easy, it's a 10. What is the common difference? Positive 5. And then let's look for the 100th term. So my first term's 10, my constant or my common difference is 5. So if I'm going to look for the 100th term, I'm going to use my first number, 10, plus 100 minus 1 times 5. And that gives me 505. Given the following arithmetic sequence, 6, 4, 2, 0, negative 2, you can see by looking at this one that it's going backwards. So what is the common difference? Looks like it's negative 2. And what is the value of the 10th term? Let's give it a try. The first term was 6. Let me make sure I have that. Yep, first term is 6. T1 is 6. The constant, or the common difference, is negative 2. So the 10th term is equal to the first term plus 10 minus 1 times negative 2, which is negative 12. For the arithmetic sequence that's provided, which term in the sequence has the value of 212? So your first term is negative 3, and your constant is 5. So I've got this sequence is actually equal to 212. I don't know what it is, but my first term was negative 3. Yep. And then it's n minus 1 times the constant, which was 5. So go ahead and distribute that, clean this up, add the 8 over there, you get 44. Okay, determine the first term in an arithmetic sequence in which the 20th term is 112 and the difference is 6. So the 20th term is 112 and the common difference is 6. So you know that it's going to be equal to 112. We don't know what T1 is. Plus, now this one is always 1. Let's see where we are here, 19. You're going to have 19 times, because if you're looking for the 20th term, I just had a mental freeze there. We're looking for the 20th term, that's it. So we're going to have 20 minus 1 times the constant, which is 6. And so there you have your answers when you do the algebra is negative 2. Okay, the last type of question is the following. Now this is a little bit more challenging because of the math in order to solve it. What we have are two terms. We've got the 8th term, which is equal to 21, and the 27th term, which is 97. And we needed to know that this was arithmetic, actually. But what we don't know is the first term, and we don't know the constant. So when you have two things that you don't know, the first term and the constant, in two different scenarios, this should remind you of something we call linear systems. So here I have it. I'm going to rewrite them. And then I decided I would put them around so that they were in a good format to use elimination, I think is what I'm doing. So I eliminated and I found out that the constant was 4. Once I knew that the constant was 4, then I could find the other guy at negative 7. Okay, so my nth term, and I believe, let's just make sure we remember what we're supposed to do. We're supposed to find the nth term, okay. T1 plus n minus 1d, the first term turns out to be negative 7, and the constant was 4. So yeah, putting it all together, you have an answer of 4n minus 11. So there you have it, our lesson on section 1.1. Here would be your homework. And make sure that you do only the odd letters, please. I don't want you to do every single one, just the odd ones. Okay, good luck, everybody.